Okay, on this example, we're told that Q's quantity, P's price, demand function is given to us, where P equals 300 minus 0.02 Q. Now, demand functions always connect together price and quantity. Sometimes P is on one side by itself, as it is in this case. Sometimes Q is on one side by itself. All right, the goal on this problem is we're going to calculate the elasticity of demand when the price is $70, and then figure out should we increase our price or decrease our price maybe to increase our revenue, right? That's the end goal on this, is increase your revenue. You want to know, is our price set right? Should I increase it? Should I decrease it? All right, so the formula is listed over there on the elasticity of demand formula. One thing to note on this, though, is this dq over dp means the derivative of q with respect to p, or in our other notation with prime notation, this is q prime. In both these cases, it's important that our demand function has q on one side all by itself. And this is what throws a lot of students off, is you try to get started on this, but you kind of go the wrong direction if you don't have q on one side by itself. So you notice on our demand function, p is on one side by itself. We should really rearrange this and solve for q to begin with. So to do that, I'm going to go ahead and subtract 300 from both sides, and then divide both sides by negative 0.02. So as I do this, negative 0.02, negative 0.02, that'll get q on the right-hand side all by itself. But I'm going to go ahead and say, well, I can split this up. P divided by negative 0.02 minus 300 divided by negative 0.02. And this will actually simplify down to negative 50p plus 15,000. All right, so that's what we have for Q. I'll clean this up and make it look just a little bit nicer, but that's going to be representing Q. It's just rearranging that demand function that was given to us. All right, some other things that we can start answering on this. One thing we want to know is, what is our price P? Well, that was given in the original, that we want a price of $70 to compute, our elasticity of demand. Now, our quantity that we're going to be selling, if we charge $70, will be if we take 70 and we plug it into this demand function. So 50 times 70 plus 15,000 is going to be our quantity Q. All right, so that's negative 3,500 plus 15,000, or our quantity should be 11,500. All right, the very last thing we need is we need dq dp, the derivative of q with respect to p. So to get this, I'm going to go to our demand function with q on one side by itself, and we can get dq dp will be negative 50 using the, it's a linear function over on the left-hand side, so it's going to be the slope of that linear function. So in this case, we don't have a variable with that, it's just going to be negative 50. So to finish this up, let's actually calculate the elasticity of demand. So that's going to be P, 70, over Q, 11,500, multiplied by dq dp, which is negative 50. Close my absolute value signs off. And this works out to be, let me think, this is going to be negative 3,500 over 11,500, or that's going to be approximately 0.3, and then it goes on 0.43478, keeps going, right? All right, so to answer their question, oh yeah, and we did make it positive as we dropped the absolute value signs. So interpreting that, all right, first of all, we say that's a value that is less than 1. So when it's less than 1, we refer to that as inelastic. All right, so when something's inelastic, what that tells us is we should actually raise prices. And why we should do that is reading down here below, interpreting it is for every 1% we increase the price, the demand is going to decrease only by E%. And I say only by E% right now because we just found our elasticity of demand to be 0.3, right? So that's less than 1. So whenever this number is less than 1 that comes out, that tells us that by increasing our prices by 1%, the demand's not going to decrease by 1%, right? So if this is a number smaller than 1, raise those prices up, and you're going to increase your revenue. So I hope this helps out as you're trying to understand elasticity of demand and filling into the functions. Good luck.